All right, today we're going to be looking at Introduction to Conic Sections. What exactly is a conic section? And we'll be looking specifically at lines of symmetry in those conic sections. All right, so before we start working with conic sections, what exactly are conic sections? Well, just like the name implies, basically it's just a section of a cone. So what I have here is a cone, and basically what happens is, depending on how I slice this cone, I can get one of four different shapes up there. All right. So if I cut this thing horizontally across here, I end up with a circle. That's our first conic section, right over here, circle. Now, if I slice this at a slight angle, instead of getting a circle like I do here, what I end up with is instead this shape right here. What is this shape called? No, because I'm ellipse. This is called an ellipse. Okay? Now, the next one, hyperbola, we've seen this before. Basically, if I had two cones, one stacked on top of each other, and slice this vertically, what I end up with here, and I want to tilt this, is I'm going to end up with two parabola looking like sections here. We call that the hyperbola. And of course, the last one, as you can see, if I slice it, I end up with a parabola as well. So these are the four different shapes that we can get from slicing a cone. Okay? Now, lines of symmetry. This is what we're going to be looking at today specifically. A circle. Anybody remember how many lines of symmetry a circle has from geometry? First of all, y'all remember what line of symmetry is, right? What is it? It's the line that cuts it in half. The right side would match up with the left side if we fold this together, right? So my question is, how many lines of symmetry does a circle have?
Wait, one.
Just one? Two? No, more than that.
It's infinite.
There's lots and lots and lots of lines of symmetry, guys. Basically, anything that goes through the center of our circle is considered to be a line of symmetry. Okay, so I need you to write that down for me. A line of symmetry in our circle is going to be any line that goes through the center. Any line. As long as it goes through the center, it's considered to be a line of symmetry. And there's lots and lots of lines of symmetry in a circle. Now, ellipse. How many lines of symmetry does an ellipse have? How many different ways can we cut this in half so that the right side would match up with the left side? Two. There's only two on this one. There's a vertical and there's also a horizontal line of symmetry. By the way, notice that both of those, vertical and horizontal line of symmetry, both of those would have to go through the center. All right, so there's two of them, a vertical and a horizontal. Our hyperbola is also going to have two lines of symmetry. It's going to have a vertical and a horizontal as well. And it's also going to go through the center. So ellipse and hyperbolas have two lines of symmetry, vertical and horizontal. Both go through the center. Now, the parabolas, you'll notice over there on the parabolas, we've seen parabolas before, but this time what we're going to see is we're also going to see parabolas that open up sideways, left and right. Up to this point, we've only seen parabolas that open up and down. Now we're going to see some that open up sideways. But when it comes to parabolas, we're only going to have one line of symmetry. It's either going to be a vertical or a horizontal line of symmetry, depending on how the graph looks. If it's up and down, it's a vertical line of symmetry. If it's laying down sideways, well, then it's a horizontal line of symmetry. So it's only one or the other. It's not both. Lines of symmetry. And that's what we're going to look at today. Lines of symmetry in each of these conic sections. But before we do that, I just want to kind of briefly introduce some vocabulary for each of these sections here that we'll be looking at later on. Like circle, we should all know that a circle has a center, it has a radius, and it also has a diameter. A circle has a center, a radius, and a diameter. And we'll be looking at those three things tomorrow when we start looking at circles. an ellipse. Ellipse also has a center. It has vertices. And it also has something called a major and minor axis. More specifically, a major and minor axis of symmetry. But we'll talk more about those things later on. Probably won't get to that till about Wednesday or Thursday. Some parts of the hyperbola that we'll be looking at will be the center, vertices, and asymptotes. And for our parabola, a couple of things that we're going to be getting familiar with is vertex and axis of symmetry. There are some other things that we'll talk about as well, but for right now, these are some things. Vertex and axis of symmetry. Now down there at the bottom, some applications, some places that we might find circles, ellipses, hyperbolas, and parabolas. So the first one here, circles. We might see those in wheels or CDs. Those are some examples of applications of a circle. As far as an ellipse, some applications would be something called a whisper room, or the orbit of planets. Anybody know what a whisper room is? Never heard of a whisper? That's right. Basically, it's a big room that's in the shape of an ellipse, and if one person were to stand on one side and another person stand on the opposite side, we'd be able to hear what they're whispering. And it all has to do with the shape of the room.
Was it orbits of planets?
Orbits of planets, yeah. It takes an elliptical path. Hyperbola, some applications there might be the shadow on the wall from a lamp, the cooling tower of a nuclear reactor. These are some places that we might find hyperbola. And the parabola. One place we can find a parabola would be in the shape of a satellite dish. We use those quite a bit in satellite dishes. And the path of a projectile, like shooting a basketball, hitting a golf ball, the path of the water in a fountain. These are all a parabolic shape. So these are a few applications of each of the conic sections that we'll be looking at. There's lots and lots and lots and lots of others. So again, this is just a brief introduction on what exactly is a conic section. And you'll notice that you all have been familiar, subjective to each of these shapes here. You know what a circle is. You've seen an ellipse. You've seen the hyperbola before. And we've also talked about parabolas. But we're going to get a little more in depth on each of these shapes here. All right, so let's turn to the next page. Today what we're going to do is we're going to focus in on the lines of symmetry in each of these conic sections. So up at the top it says, in each exercise, part of a conic section is drawn. Use the symmetry of each shape to complete the graph and write down the other information that's requested. So here they give us part of a circle, and they tell us that the center of this circle is at 0, 0, which of course is right here. So if 0, 0 is the center, and they've given me part of the graph, Samantha, could you tell me what the radius of this circle is? Could you tell me the distance from the center to the edge of the circle? Could you tell me what that is? What do you think it is? All I'm asking is, what's the distance from this center point to this point over here on the circle? 6. All right, so the radius here is 6. All it is the distance from the center to the edge of the circle. Now, it really doesn't matter. I'm using this point right here, but I could have also used this point here. The distance from here to here is also going to be 6. The distance from here to the center is also going to be 6. It really doesn't matter. It just makes it a little easier to see visually from here to this point up here. Okay, but there are several others. All right, so here's what we're going to do. They want us to approximate coordinates for points of the circle in the first quadrant. This over here is the first quadrant. So what we're going to do is we're going to write down a couple of points that will fall into the first quadrant. And what we're going to do is use the fact that we know that there's a line of symmetry that runs right down the middle here. So I'm going to draw that so you can see it. There's that line of symmetry. Which means if I have a point on the left side of that line, there should also be a point that corresponds to it on the right side of that line. So in other words, this point right here, there should be another point directly across from it over on the right-hand side. What would it be? Positive 3, 5.2. I'm going to write that down over here. Positive 3, 5.2. And I'm also going to graph that point. Positive 3, 5.2. All right. Let's do the same thing with this other point. If there's a point on the left side of my line of symmetry, there should also be one on the right side of that line of symmetry. So where exactly would it fall? What order pair? 5 and 3.32. So let's put a dot there. Here's my 5. Here's my 3.32 right there. Now notice that we could also put a dot on the x-axis. Where exactly would it fall on the x-axis? At 6. Remember, we said the radius was 6 units. So we could also put one there. So I'm going to go ahead and connect these dots and make the other part of my graph. All right, so those are some points in the first quadrant. Now what they want me to do is approximate coordinates for points in the circle that are in the fourth quadrant. Okay? So this over here would be the fourth quadrant. What are some points that would fall in the fourth quadrant? Well, again, remember, we have a line of symmetry and the circle has lots of them. So we're also going to have this horizontal line of symmetry. So if there's points above that line, there should also be corresponding points below that line. So I'm going to start with this point right here. That point we said earlier was 5, 3.32. There should be another one right below. Where would it be? What would the order pair be? 5. There it is. 5, negative 3.32. So let's find it. 5, negative 3.32. Somewhere about there. Now let's find the one that's across the y-axis from this point. Where exactly would that one fall? Remember, that order pair we said was 3, 5.2, 3, and negative 5.2. So go ahead and find that one. 5, that was 3, negative 5.2. Looks like it's about right here. And of course, don't forget, we did say the radius was 6. So from the center, if I go 6 units, that would give me another dot right there. And of course, now I can connect all of these dots. Get that circle. And all I got to do now is finish up the third quadrant. Anybody want to tell me what some points that we might have in that quadrant there? What would be the one directly across from negative 5, positive 3.32? What's the point that corresponds to that? Negative 5. There it is. 5, negative 5, negative 3.32. And the point that corresponds to this one would be negative 3, negative 5.2. Connect those dots. And now we have our circle. So all we're doing is using these lines of symmetry to come up with a few more points to graph. Now obviously the more points we have, the more accurate our graph is going to be. All right, we're going to skip number 2, and we're going to jump on over to number 3. So go to the next page. Let's take a look at number 3. This time what we're doing is we're looking at an ellipse. An ellipse. Now here's what they tell me about this ellipse. The center of this ellipse is going to be at 0, 0. So I'm going to go ahead and put a dot there at 0, 0. They give me a couple of other things. They give me the vertices. Now there's 4 of them. I know it's kind of hard to see, but there are 4. Right here there's 2, and right here there's also 2. So the first order pair is positive 7, 0. So I'm going to put a dot at positive 7, 0, which is right over here. But in that same ordered pair, they're also telling me that there's a negative 7, 0. So let's put a dot over here at negative 7, 0. So these are 2 vertices on my ellipse. The other 2 vertices are right over here. There's 0, positive 4, which would be this point right here. And there's also a 0, negative 4. That's this point down here. So these are going to be my vertices of this ellipse. Now there's a couple of other points that they give. They're telling me that in the first quadrant we're also going to have these 2 points. So let me go ahead and graph those 2 points. Here's 3, 3.61, which would be right about there somewhere. And 5, 2.8. So here's 5, 2.8 is going to be right in this area here. So these are the other 2 points that they've given. So if I were to connect these, this would give me part of my ellipse. Of course, that's not enough to graph the whole thing, so we're going to get a couple more here. What they want us to do is list some more coordinates, 6 other points on this ellipse. All right, so we're going to find 2 in the second quadrant, 2 in the third quadrant, and 2 in the fourth quadrant. Now, they've already given me one of the order pairs that would fall in the second quadrant, and that's negative 3, positive 3.61. That's this one right here. So they've given me that. And how do I know that's one? Because remember, there's 2 lines of symmetry here. There's a vertical line, and there's a horizontal one. So now I want to find the one that corresponds to this point over here. So where is it going to be? It's going to be on the left-hand side over here. What point would that make? Remember, this point right here is 5, 2.8. So where would this one be over here?
Negative 5.
There it is, negative 5, positive 2.8. So let's go ahead and find that. Negative 5, positive 2.8. That's about right here. So if I connect these dots, I get this shape right here. Now let's find 2 points that are in the third quadrant. And I'm going to use this line of symmetry again. Right here, the horizontal line. This point right here, there's a corresponding point on the opposite side of the line of symmetry. So where exactly is it going to fall down here in quadrant number 3? What order pair would it be? Remember, guys, this order pair right here is negative 5, positive 2.8. So where would the other one fall? Negative 5, negative 2.8. So that's going to put it right about there. Let's find another one. This point right here we said earlier was negative 3, 3.61. So the one that's on the opposite side of that line of symmetry would be what? Negative 3, negative 3.61, which would be somewhere around here. Now we can connect those points. By the way, let's go ahead and make sure we're writing those down. What were those 2 points again? Negative 5, negative 2.8. Notice they're the same thing, guys. All we're doing is adding a negative sign to our y value. All right, we got 2 more to find, and that's in the fourth quadrant. So let's use these points that we had earlier. Let's find the corresponding points. Let's start with this one over here. This point over here was 5, 2.8. So the one that's corresponding to that one would be what? 5, negative 2.8. So 5, negative 2.8 would be about here. Now let's find the point that corresponds to this one. And that point we said was 3, 3.61. So our new point is going to be 3, negative 3.6. It's on the opposite side. 3, negative 3.6. Connect those dots, and we have our ellipse. So again, the more points we have, the more accurate our graph is going to be. That is an ellipse. All right, I'm going to skip number 4. I'm going to let you go back to that one in a minute. And I want you to jump to number 5. Let's jump to number 5. This time what we're going to do is we're going to look at the parabola. Now, like I said earlier, usually the problems that we've seen have gone either up or down. They open upwards or downwards. This time they're opening up sideways. Here, this parabola, they give us the vertex, and it's at negative 4, 3. That's this point right here, negative 4, 3. They also give me the axis of symmetry. It's y equals 3, which is this red dotted line. That's the axis of symmetry. That's the line that's going to cut our U shape in half. They've also given me some ordered pairs that are on this U shape. One of those points is negative 3, positive 4.2. So let me find that one. Negative 3, positive 4.2. They're referring to this point right there. 0, 5.4. They're referring to this point right here. And the other one they give me is 5, 6.6, which is this point right here. So they've given me these points. What we're going to do is we're going to attempt to find the ones on the opposite side of that line of symmetry. Now, keep in mind this table that we're trying to fill out over here. They're asking us to approximate the coordinates. So we want to get as close as we can. For example, this point right here. There's one directly across from it, from that line of symmetry. Where would it fall? Well, let's see. It's 1 and a little more than that, so it's 1 and a little more, so that would place it right about here. What is that point? What is that ordered pair? Remember, this is just an approximation. What would that ordered pair be? Well, but I want the whole ordered pair. Negative 3, 1.8. And they've actually given us that first one there, guys. Negative 3, 1.8. Let's find the one that corresponds to this point. Now again, notice how far it is from the axis of symmetry. Notice it's 1, 2, and a little more. So I'm going to go 1, 2, and a little more. That would place it right about there. So the question is, what does that ordered pair look like? Keep in mind this is only an approximation. What would you call that ordered pair? 0 and 0.5, 0.6, whatever. I'll go ahead and use 0.6. This is just an approximation. Now let's attempt to find this one last one here. Notice how far it is away from the axis of symmetry. Notice it's 1, 2, 3, looks like about 3.5 units. So if I go 1, 2, 3 in the opposite direction, that would place it right about there. So the question is, what would you call that ordered pair? 5 and negative what? 0.5, 0.6. Again, this is just an approximation. We'll call it 0.5. All right, so now that I have those points, if I connect all of these points, I end up with the other half of my parabola. So this is a parabola that has a vertex of negative 4, 3, has an axis of symmetry at y equals 3, along with these other points here. All right, what I'm going to want you guys to do is go back and finish up the other 3 points. Use the line of symmetry to come up with some more points and give me the rest of the graph. When you get done with it, you can turn it in for me.